Okay, so the next topic that came up in the 2016 paper was this one, where you got to use the remainder theorem and the factor theorem. Now, the main thing to remember is that the remainder theorem and the factor theorem are pretty much the same thing, and that's where you make this bracket equal 0 and see what the remainder is. So if we've got 2x plus 3 equals 0, 2x equals minus 3, x equals minus 3 over 2. So then what we do, to find the remainders, we substitute minus 3 over 2 into this thing here. So you're going to have 6 lots of minus 3 over 2 cubed plus 13 lots of minus 3 over 2 squared minus 4. Remember to put the fraction in brackets because it's negative. So when you square it, it's obviously going to get rid of the negative sign. And then if you shove that into your calculator and press equals, you should get the remainder as 5. Use the factor theorem to show that x plus 2 is a factor of f of x. So, again, we substitute in x equals minus 2. So it's going to be 6 lots of minus 2 cubed plus 13 lots of minus 2 squared minus 4. But notice that this one is a show that question. So when it says show that, it means that you've got to do a little bit more workings. So it's going to be 6 times minus 2 cubed is going to be minus 8. Plus 13 lots of minus 2 squared is going to be 13 times 4, then minus 4. So that's going to be minus 48 plus 52 minus 4, and that equals 0. So 0 remainder means x plus 2 is a factor. That's enough to get you the marks for that one. So factorize f of x completely. So if we know that x plus 2 is a factor, it means that when we do x plus 2, when we divide that into 6x cubed plus 13x squared minus 4, it means that we're going to get no remainder. So the way we do this is, what do we multiply x by to get 6x cubed? That's going to be 6x squared. So 6x squared times x is going to be 6x cubed. 6x squared times 2 is going to be plus 12x squared. We then subtract it. So we do the top line, take away the bottom line. So 13x squared take away 12x squared is going to be 1x squared. Minus 4, and there's nothing else there, so add minus 4. Because this is x squared and there's nothing else, what we might want to do is write plus 0x minus 4. And that way we've got x squared, we've got x's, and we've got minus 4. So now the next thing is, what do we multiply this x by to get x squared? So that's going to be plus x. So we're going to multiply everything by x, and that's going to be x squared plus 2x. Then we're going to do the top line here, take away the bottom line. So x squared take away x squared is 0. 0 take away 2x. Just be careful with this. It's the top line, so it's 0x take away 2x. That's going to be minus 2x minus 4. Then would you multiply this x by again to get minus 2x? That's going to be minus 2. So if we do that, minus 2 times x is going to be minus 2x. Minus 2 times 2 is going to be minus 4. And we know we've done it correctly because we get a 0 there. So now what we can say is that x plus 2 times by 6x squared plus x minus 2 equals our function of x. However, that's not factorized completely. That's factorized a little bit, but not completely. Because what we've got to do now is we've got to factorize this bracket here. So 6x plus 2, so 3x and 2x plus 2 minus 1. So that works. That's going to be 4x minus 3x going to be plus 1x. Yeah, that works. And that equals f of x. And now that's factorized completely. So that's the whole premise behind using the remainder theorem and the factor theorem. And again, the questions don't change an awful lot from year to year. Oh, sorry, let's find the appropriate question for the 2015 paper. Oh, pause the video. That's better. Right, so now exactly the same thing. So given that when f of x is divided by x plus 1, the remainder is 45. So it's kind of reverse, but it's the same question. So we're saying that when we substitute in x equals minus 1, the thing that makes this bracket 0, we get it equal to 45. And then we show that b minus a equals 48. So that's what we need to arrive at. So we're told that 45 is the remainder, and that's when we substitute in minus 1. So it's going to be 6 lots of minus 1 cubed plus 3 lots of minus 1, again in brackets, squared, plus a times minus 1, and then plus b. So 45 equals minus 1 cubed is going to be minus 1, times by 6 is going to be minus 6. Minus 1 squared is going to be 1, times by 3 is going to be plus 3. A times minus 1 is going to be minus a, plus b. So again, I put in the extra line of work in. Minus 6 plus 3 is going to be minus 3, and then plus b minus a. And get rid of minus 3 by adding it to the other side, so we end up with b minus a equals 48. And that's enough to get us the first 2 marks. Given that 2x plus 1 is a factor, now if this is a factor, 2x plus 1 equals 0, 2x equals minus 1, x equals minus 1/2. If we substitute in x equals minus 1/2, but it's a factor, we should get a remainder of 0. So we can write down 0 equals 6 times minus 1/2 cubed, again substitute it into our original here, plus 3 lots of minus 1/2 squared, plus a times minus 1/2 plus b. So now what we do is we simplify this out. So 0 equals minus 1/2 cubed is going to be minus 1/8. 6 lots of minus 1/8 is going to be minus 6/8, or minus 3/4. Minus 1/2 squared is going to be 1/2, so it's going to be 1/4. 3 lots of that is going to be plus 3/4, which is kind of handy because these two are going to cancel out. And minus 1/2 a plus b. So then these two are going to cancel out. If we get this on the other side and times everything by 2, we're going to get, well, half a equals b. And times it by 2, we're going to get a equals 2b. So now we've got to work out what a and b are. So I know that a equals 2b, and I know that b take away a equals 48. And if a is the same as 2b, then b take away 2b equals 48. So b take away 2b is going to be minus b equals 48. Then b equals minus 48. And we know that a, going back to this thing here, is 2 lots of b. So then a equals 2 lots of minus 48, which is minus 96. And then we've got to, for part C, factorise this thing up here fully. So what we can do is we can write out what it is properly now. And that's going to be 6x cubed plus 3x squared. And instead of plus ax, we know that a is minus 96, so that's going to be minus 96x minus 48. And we know that 2x plus 1 is a factor, so we need to put 2x plus 1 on the outside. And we're going to do long division to get ourselves a quadratic, which is going to be up here. So what do we multiply 2x by to get 6x cubed? That's going to be 3x squared. So times everything by 3x squared, and you're going to get 6x cubed plus 3x squared. So if we take that away, we're left with minus 96x minus 48. What do we multiply 2x by to get minus 96x? And that's going to be minus 48. And if we multiply everything by minus 48, so multiply 2x by minus 48, we get minus 96x. Multiply 1 by minus 48, we're going to get minus 48. That's with 0 remainder, so we haven't made a mistake. So now we can say that 2x plus 1 times by 3x squared minus 48. Oh, apologies. Minus 48 equals f of x. But again, it says factorise that fully. So what we're going to need to do here is we're going to need to take out, or we need to factorise this bit fully. Now, it doesn't look immediately obvious how to factorise that. So if you ask a GCSE student to factorise that, or even a Key Stage 3 student, what they're going to do is they see that 3 goes into both of them. So if we take 3 outside, we're going to get x squared minus 16, and then it looks a little bit easier to factorise. So if we factorise that, It's going to be the difference of two squares. So it's going to be x plus 4, x minus 4. And then again, that's that question done. So that's another 9 marks. So that was a 2015 paper. Now, a 2014 paper. Again, question 2, so it's not going to be too strenuous. But again, it's looking pretty much the same thing. Use the factor theorem. Now, the factor theorem and the remainder theorem are the same thing. X minus 2, we set the bracket equal to 0. Therefore, x equals 2. So the factor theorem means that if we substitute this in, we should get 0 remainder. So we're going to do 2 lots of 2 cubed minus 7 lots of 2 squared plus 4 lots of 2 plus 4. So that's going to be 2 lots of 8 minus 7 lots of 4 plus 8 plus 4. So 16 minus 28 plus 8 plus 4 equals 28 minus 28, which equals 0. So 0 remainder. Therefore, x minus 2 is a factor. So with the whole factor theorem questions and the show that questions, make sure you just take the extra 30 seconds to do that extra line of work in just because it says show. Okay, so factorize completely means that x minus 2 goes into this without any remainder. And again, that's an important piece of knowledge to have at your disposal. Because if you know there's not going to be any remainder, if you do get remainder, it means that you've made a mistake. So 2x cubed minus 7x squared plus 4x plus 4. So what do we need to multiply x by to get 2x cubed? That's going to be 2x squared. Then you multiply everything here by 2x squared. So 2x cubed minus 4x squared. Now just be careful now when you're doing the subtraction. Obviously the 2x cubes go, but minus 7 take away minus 4 is going to be minus 3x squared. To bring the other stuff down. Plus 4x plus 4. And then what do you multiply x by to get minus 3x squared? That's going to be minus 3x. So times everything by minus 3x. Minus 3x squared plus 6x. And again, we do the top take away the bottom. So 4x take away 6x is going to be minus 2x plus 4. Now what do you need to multiply this x by to get minus 2x? That's going to be minus 2. So multiply everything by minus 2, minus 2x plus 4, and again we get 0 remainder, so therefore we can be confident that we haven't made a mistake. So x minus 2 times by 2x squared minus 3x minus 2. X minus 2 in brackets, and then we need to factorize that. So that's going to be a 2 there and a 1 there. So we want to make that minus 4x, and then we need to plus an x, and that's it. So there you go. That's how to do these factor theorem questions. They usually take as much time as they give you. So usually, if you've got 6 marks, that's going to be 7.2 minutes. So they usually take at least that in order to do, because there's so much algebra that you need to do. Anyway, good luck with that one.